Before we start Unit 7, we are actually going to talk about something called molarity, which is a way of expressing the concentration of a solution. So we need to do this before we talk about acids and bases. Okay, so expressing concentration. Concentration is the measure of how much solute is dissolved in a specific amount of solvent. So solute is what you dissolve. Solvent is the thing that you dissolve it in. It can be concentrated or dilute, right? You've got here an example of making tea. This one over here has a single tea bag. This one's got multiple tea bags in it. And so you can, right, just by looking at it, tell that the tea on the left side is more concentrated than the tea over on the right. There's more solute in this one, right? There's the same amount of solvent, okay, but this one's got more solute in it, more stuff dissolved in it. We're going to find out here that most commonly, at least for the purposes of our class, water is going to be our solvent. There are other solvents, of course, but for what we are doing, it's almost always going to be water. Here are several ways to express concentration of things. You can do percent by mass. You can do percent by volume. Oftentimes, if you see like alcoholic beverages, they're measured in ABV. That's alcohol by volume. That's oftentimes how it's represented. So if you see that percentage, that's what it's talking about. There's molarity, which is the one that we are going to use. Molality is very, well, it's very specific. We're not going to see this in a general chemistry class. And we're not likely going to put things in terms of mole fractions. We're almost always going to use this unit, molarity. Okay, so what is it? It's the number of moles of solute dissolved per liter of solution. If you want to think of it, okay, molarity is moles per liter. Moles per liter is the unit here for that. All right. It's also called molar concentration. This italicized capital M is the abbreviation. I know there's a lot of M's in chemistry. There's moles, there's molar mass, but this italicized capital M will represent molarity, so that's the concentration of a solution. The units are moles per liter, and how it's written is the concentrations are written with brackets around whatever the solute is. So for the example here, you would read this as the concentration of calcium chloride is equal to 0.150 molar. Okay, that's how you read that. The concentration of whatever's in the bracket equals blank molar. Okay, is how you read that. Right, the equation for it down here, moles of solute divided by liters of solution. So we make sure that the top of this is in moles and the bottom part is in liters and not milliliters. Okay, so how we calculate molarity, what is its use? Well, we're going to use it to talk about how concentrated an acid or a base is eventually. That's where this is heading. But we can do this with anything that will dissolve in solution. So if we're in a lab and let's say you need to make a very specific concentration of something, you need to know how much to weigh out on a balance. So let's say you're in the lab and you need to prepare 2.00 liters of an aqueous solution of 1.25 molar CuSO4. In just in case you've forgotten, right? If you see aqueous there, that means the solvent is water, right? It's giving us the molar mass. So how much CuSO4 in grams do you need to measure out to make this solution? Okay, as chemists and chemistry teachers, we do this stuff all the time. We have to make solutions for labs, and so we do these calculations quite a bit. So what do we need to do to solve this? Well, right, we need the equation that we just learned. Molarity is moles divided by liters, and we will need our equation from the previous semester of moles equals grams divided by molar mass. Ultimately, we're trying to get to grams here. So let's first look at this. We are given, right, for molarity equals moles over liters. We're given a molarity, we're given a volume. We have this, and we have this. We can solve for moles. So if we rearrange this equation for moles and bring liters up to the other side, we have molarity times, and we'll call this volume, right? Okay, because liters is, right, a unit of volume. Well, we can just plug those things right in. We have a molarity of 1.25 molar and a volume of 2.00 liters. Okay, and that would give us, what, 2.50 moles. Okay, and then from there, we can plug this into the equation over here. We have the moles now, and I also have the molar mass from the problem. So rearranging this equation, draw an arrow and put it down like this, rearranging that equation for grams, grams equals moles times molar mass. Well, we have the moles are 2.50 moles. The molar mass is 159.62 grams per mole. And that's going to give us, let's see, we'll call it to three significant figures, 399 grams of CuSO4. Okay, so this is what you would need to weigh out on a balance to make this particular concentration and needing 2 liters of it. So just kind of for reference here, like what's a strong concentration or a weak concentration? A concentration of 1 molar means you have 1 mole per 1 liter of water. And so that's kind of your marking where if it's less than that, it starts becoming more and more dilute. We can have things very dilute, 0.001 or less. Okay, that's certainly possible. Anything where we start getting over a couple molar, like very concentrated acids are greater than 10 molar. So that's kind of your marking where things get really concentrated and potentially dangerous depending on the substance. But we can also certainly dilute them down with water and make them not quite as bad. We'll do one more together here, and then we'll have you try one. So this says 2.56 grams of silver nitrate, AgNO3, is dissolved into 0.100 liters of water. What is the molarity of the solution? So ultimately, I'm trying to find my molarity, which means I'll do moles divided by the volume in liters. Well, we're given liters, we need to calculate moles. So let's first do the equation over here and plug in the numbers for that. 2.56 grams divided by the molar mass given to us is 169.88 grams per mole. And we'll do that to 3 significant figures. Let's see, that's going to give us 0.0151 moles. And we can then plug that into the equation here. Molarity is equal to 0.0151 moles divided by a volume of 0.100 liters. That's very convenient. 0.151 molar would be the answer there, right? And how you would write this, you could write the concentration of AgNO3 is equal to 0.151 molar. Okay, that's what that would look like. All right, we'll give you a few minutes here to try this one on your own, and then you'll see the solution for it. Okay, here's the solution for you. We're going to start by calculating moles by taking grams divided by molar mass, and that gives us 1.066 moles. We're then going to rearrange the equation for molarity to solve it for volume, so we'll solve it for liters. It's equal to moles times molarity, 1.066 moles times 0.250 molar. You get 0.267 liters, or that is 267 milliliters. Okay, so here's another useful tool with molarity. It has to do with diluting a solution. And so as chemists, we oftentimes have to dilute stuff down because it comes to us very concentrated. It makes sense for shipping purposes, right? If it's very concentrated, you have to ship less volume, which makes it cheaper. So they send stuff to us very concentrated, and we have to dilute that down to make it safe to use. So a good example of this is hydrochloric acid, which we'll learn about soon enough, HCl. It's purchased at 12.0 molar. That's very concentrated. That's not something you'd want to get on you. However, the solution is way too concentrated for lab work. It needs to be diluted. So let's say a 0.250 liter aqueous solution of 12.0 molar of HCl needs to be diluted to 1.25 molar, right? So we're going from 12 down to 1.25 molar. This is still pretty concentrated, but a lot safer than what it originally started as. How much water must be added? Okay, and so there's a very useful equation for this problem. M1V1 equals M2V2, right? So what we're doing is we're starting with 0.250 liters of very concentrated substance, and we're adding a bunch of water to it to dilute it down to make it 1.25 molar. Here's the equation. And what this means is initial molarity times initial volume equals final molarity times final volume. And we're going to solve this on the next slide. Okay, so I went ahead and got my numbers from the previous page. Initial molarity is 12.0 molar, and the initial volume is 0.250 liters. The final molarity is 1.25 molar, and I'm looking for, right, it said how many must be added, but let's first find what the final volume must be. So let's rearrange this equation to solve for V2, right? Get V2 by itself. So we'll divide both sides by M2, and then let's just start plugging stuff in. Initial molarity is 12.0 molar. V1 is 0.250 liters, and M2 is 1.25 molar. And we're going to round that to 3 significant figures. So let's see, we got 12.0 times 0.25 divided by 1.25. This comes out to being 2.40 liters. Okay, and this would be the final volume, right? If it asks, what's the final volume that you would need to turn it into, that would be correct. The question, though, asked how much must be added, right? How much must be added? How much water must be added? Okay, that's a different question. If it said, what's the final volume, we'd say 2.40 liters. But how much must be added? Well, we didn't start at 0. We started at 0.250 liters. That was my initial volume. So to figure out how much must be added, we'll take the 2.40 liters and subtract from that the initial volume of 0.250 liters. We're going to round this to the hundredths place, okay, and that's going to give us, let's see here, so 2.4 minus 0.25, that's 2.15 liters, okay. It's a tiny little difference, right, in terms of what the question's asking you to do. If it's asking for what's the final volume, well, it's just whatever you calculate for V2. If it says how much water must be added, well, subtract your initial volume from whatever your final volume is, and that is how much you needed to add. There's going to be one on the next slide for you to try on your own, utilizing this M1 V1 equals M2 V2 equation. Okay, so this time around, the question's asking about how many milliliters of the stock solution do you need. So you don't need to do any subtraction or anything at the end. Just solve for V1, right? That's what this is. So use your equation that you just learned for dilution of a solution, and we'll check in here in just a moment. Okay, so we're solving for V1. Rearrange the equation for V1. That's M2 V2 over M1. What I went ahead and did was just label everything up here with M1, M2, and V2. M2 is 0.100 molar. V2 is 2 liters. Divided by M1, which is 14.3. Notice you get a very small number here, 0.0140 liters to 3 sig figs. That's 14.0 milliliters. So you don't need a whole lot of your 14-something molar stock solution to get just a 0.100 molars and 2 liters of it. You need just a tiny bit. So hope you did well on that, and we'll see you next time.